Good morning. My talk today examines the state of the art of the continuous monitoring of gas emissions in volcanic islands. A suitable case study is Vulcano, which is still active in the Aeolian Islands after the last explosive eruption that occurred in 1888 to 1819. Vulcano shows fumarolic sulfataric activity and gas emission from the soil. A geochemical monitoring network allows continuous monitoring of diffuse degassing and several parameters in thermal groundwaters. During late summer to winter 2021, Vulcano showed signs of unrest, and the geochemical monitoring network provided valuable information on the volcanic degassing that were used for gas hazard evaluation and risk management also. I am Roberto and I am working with this research group at INGV in Palermo. In this talk, I intended to outline the topic of the volcanic degassing and the consequences of the soil CO2 emissions at Vulcano. In the central part of the talk, I'll examine three aspects of the continuous monitoring network, that is to say, the data acquisition, the data management, and the data processing. Finally, I'll summarize both the state of the art and the perspectives of the geochemical monitoring network at Vulcano. The slide here focuses on the diffuse degassing of CO2 at Vulcano Porto. The histogram here shows the amount of volcanic CO2 released from either anomalous or not anomalous zones at Vulcano. This estimate for May 2015 show that volcanic CO2 emitted by diffuse degassing is almost 30% the CO2 discharged by the crater fumaroles. The soil CO2 partitioning between biologic and volcanic components show a notable increase of volcanic CO2 emitted by soil in late 2021. The volcanic to biogenic mass ratio was lower than 5 before 2021. In October 2021, that ratio increased up to 17. Diffuse degassing of volcanic CO2 is laterally inhomogeneous at Vulcano, and it is focused in the zone of Palizzi and Faraglione. In summary, these results show that the position of the anomalous degassing zones did not change through time. An input of volcanic CO2 increased the gas hazard at Vulcano because of high gas emission in the settled zone of Vulcano Porto. So, I have discussed the target of the geochemical monitoring network. Now I'd like to turn to the description of the system we have designed and implemented for data collection and data management. To face the gas hazard at Vulcano, we improved the soil CO2 flux monitoring network to evaluate the changes of gas hazard level through time and provide indications of its short-term evolutions. The warning network includes 4 new stations that were installed in the zone of Faraglione. The Carapezza station is the benchmark outside the anomalous degassing zone. The stations are deployed to measure the soil CO2 flux, the air CO2 concentration at 2 levels above the ground, and the weather parameters, that is temperature, pressure, and rain, because they affect both the soil gas flux and the air CO2 concentration. The monitoring stations were fully designed and developed in the laboratories of INGV for the hardware and the software components. The automatic station allows multiple measurements, soil CO2 flux by implementing the dynamic concentration method, air CO2 concentration at 2 heights above the ground. The station includes sensor components, data logging unit for acquisition, recording, and transmission of the measurements, and the power units. The GasNet data logger for geochemical data records the measurements on the hourly basis and sends the log file on the internet to a web interface. GasNet data logger has a SD card to store lots of data. Various ports allow connecting sensors and monitoring probes, enabling a fully customizable data logging. Running for file hosted on the EEPROM memories enable the station configuration and the scheduling of the measurements. Web server and AGNT software help remote data download on request and rescheduling of the station. The GasNet web interface for station configuration includes the configuration setup, the station ID with connection parameters and data broadcast, data recording setup, and a submask for calibrating sensors and probes. The submask of the station status interface includes on-off status, power supply status, clock settings, online test for the sensor on board. Moving on the data storage, this picture shows the archive architecture of the monitoring network. Volcano gas and volcano water store data on board each station, and transmission occur once a day by scheduled database request. Let's look at the main database, which receives data by 4 stations of Volcano Ads monitoring network. Data update occur on the hourly basis. Currently, the main database performs a query on the DB and receives data from Volcano Ads and Volcano Water. In the perspective of improving the monitoring network, also Volcano Gas and Volcano Water stations will transmit data to the main server on the hourly basis as Volcano Ads do. Finally, the main database copies validated data and analysis in the public database that is accessible by selected people on request by username and password. In conclusion, I would like to say that the optimization of the data transmission will provide a significant improvement in the efficiency of the monitoring network as a whole. Let me to move on the second pillar of the geochemical monitoring network, that is the software GasNet Analytics. This software was fully developed at the INGV by Sergio Gurrieri and allows data visualization, data analysis, and data processing. The software GasNet Analytics shows time series for dynamic concentration of CO2 and air CO2, allowing the construction of panels with plots for several stations of the monitoring network. GasNet Analytics has the ability to support plugins that make it possible to extend and customize its functions conveniently and quickly. Plugin is a non-standalone software that interacts with GNA to extend its functionality. This promotes, on the one hand, less software obsolescence, and on the other hand, greater dissemination the more numerous and functional the plugin written for GNA software. A set of plugins is available, including Mafilt, Boxplot, and MapAlarm. FFT plug will perform signal processing in the near future. Normalization of the measurements allows consistent comparison among the different stations of the network. GasNet Analytics calculates and compares normalized data for each station. Data normalization occurs against the range of values for each station. Mafilt is the plugin that provides a comprehensive analysis of the various stations of the network, and thus it can help to show changes in volcanic degassing, as that occurred in 2021 at Vulcano. The second plugin is Boxplot. Boxplot provides statistics for a subset of measurements and is ready usable by selecting the database and the Run button. In summary, I would like to say that Boxplot.plug provides descriptive statistics for a subset made by the data collected in the last 13 days. Furthermore, Boxplot allows comparison for multiple stations at a glance. The plugin MapAlarm.plug provides an informative overview of the geochemical monitoring at Vulcano. In the map shown here, each point is a station of the network. The plugin analyzes the last measure and makes a comparison with data collected in the last day. Then, it classifies the results in comparison to threshold values that were established based on the standard deviation of the measurements recorded by each own station. In summary, the warning information includes a set of data related to each other. The volcanic warning takes shape, is up to date, and is communicated in a comprehensible, simple, and complete way. Data are collected in an archive or an infrastructure dedicated to the risk management, that is, a database. In conclusion, I believe that it's clear that volcanic degassing reinforces diffuse degassing of CO2. In the island of Vulcano, the anomalous degassing zones are stable through time, although the magnitude of the soil CO2 emission change and depends on the state of the volcanic degassing. Diffuse degassing causes gas hazard, and risk mitigation includes updated information, awareness, education, and surveillance. In the recent years at Vulcano, an automated geochemical monitoring network has been implemented for monitoring the gas emissions. The new geochemical monitoring technique allows timely collection and transmission of the measurements. Specifically designed software allows data processing, and it simplifies data analysis and information communication. Thank you for attention and good morning again. Bye.